Okay, I'm going to try to get through this video in 5 minutes, so you'll probably have to pause the video and take some notes uh, as you watch it. So we're supposed to find the arc length of the graph of the given equation, which is this 6x to the 2/3 plus 1, from the points A is this point right here. B is this point right here, and we want to find the length of that arc. Okay. So if we use this definition of the function y equals 6x to the 2/3 plus 1, the derivative is 4x to the minus 1/3. The f prime of x squared is 16x to the minus 2/3. And here's the definition of arc length when we're integrating along the x-axis. So from -8 to -1 of the square root of 1 plus f dy dx, the quantity squared. Okay. Now the other option is to solve for x in terms of y and find the length of the arc this way, from 7 to 25 of the square root of 1 plus h prime of y, or dx dy squared dy. Okay. Now, turns out that it looks like if I evaluate this way using Desmos, that I get something that looks like this, 19.3499. Doing it this way, same answer. And here are some exact values. 20 to the 3/2 minus 17 to the 3/2, or if you simplify that, you can write it this way. And just as an aside, if you think of this right triangle and use the Pythagorean theorem to find the length of the hypotenuse, it looks like it should be pretty close to that arc length, and indeed it is. Question is, what's the best strategy for actually finding that arc length? Well, here's the work involved in trying to do it this way. We're going to use trigonometric substitution to realize that if I call this theta and 4x to the minus 1/3 is this leg over 1, that using the Pythagorean theorem, that gives me this. So the substitution that we're going to use is that the tangent of theta equals 4x to the minus 1/3 over 1. And here's all the work that's involved in getting to a point where we can find the antiderivative. I won't go through all this, but there's the substitution. If we take the derivative of tangent of theta, we get secant squared theta d theta equals -4/3 x to the minus 4/3 dx. We can solve for dx and get this, but we still have this x to the 4/3 in here. And I can arrange to solve for x to the 4/3 this way. And so there's what we get for dx, which could be simplified a little bit. But the whole idea is that if I substitute tangent of theta equals 4x to the minus 1/3, this 1 plus tangent squared theta, the square root of that, is secant theta. And here's dx. Multiply everything all together, simplify. We end up here. We can use u substitution and end up with this integral. Here's the antiderivative, replacing u with sine of theta. And finally, sine of theta we can get from this little right triangle, opposite over hypotenuse. And if you simplify all that, you get this function right here. Okay, and we have to evaluate that from -8 to -1. If you do that, you get that 40 radical 5 minus 17 radical 17. Okay, if we go to board 4 and choose to solve for x in terms of y, it gets a lot easier. Okay, here is x. Put a little minus sign here to get the left branch. Here's dx dy using power rule and chain rule. Here's dx dy squared. Here's the arc length in terms of y. And take factor out a 196 and take, or rather a 1/16 and take the square root. That leaves the 1/4 out front. Anyway, it looks a lot simpler to solve for x in terms of y and find dx dy instead of dy dx. Okay, there you go. Hope that helped. If you have any questions, post a comment.